Man, I gotta say, some of the new satellite technology we have with the new GOES-R satellite, just impressive. I mean, look at these fire products. You can see immediately where stuff is happening. And there's a look at the California fires. They do look a little bit more subdued than the Oregon ones, which really got going last night. And there's a look at the Central California fires. It's almost hypnotic to look at these. Anyway, that's about all I got for California, but yeah, there's some major smoke problems out there. We can see that on the visible satellite imagery. Just terrible air quality down there. The true color imagery is showing a lot of brown, and the smoke plumes are starting to push eastward into the central U.S. as the prevailing westerlies start to take hold. And here's what the upper level patterns look like across North America. Looks like we have a long wave trough centered in the Mississippi River Valley, the eastern U.S., and then a very well-developed ridge out to the west. And it's this big ridge that's causing all those problems there in California. The high heights there being associated with very strong subsidence, dry air, low relative humidities, and then being on the fringe of this jet stream activity that's helping to whip up the winds a little bit there. And with the unstable air mass present over that area, that helps divert some of that strong momentum down to the surface and creates more problems. The polar front jet located up in Alaska and the Yukon off the top of the screen, and then diving down into Idaho and Nevada, and then coming out the east side into Colorado and up across the Great Lakes and Ontario and Quebec. Do we see a subtropical jet? Not really. The winds are enhanced a little bit down there in the Rio Grande Valley, but not very much. The 250 millibar chart should be picking up any subtropical jet, and we're just not seeing it. This whole pattern is very reminiscent of what we see in October. This is not really an early September pattern. And breaking this down further, looks like there's a upper level low somewhere in western Wyoming. And then somewhere in here there's a trough. Can't really pick that out, but could be one in through there. However, going back to our basic rules of thumb, trough out west, ridge out to the east. This is going to be an embedded shortwave ridge there. We would expect there to be a frontal system in between, something like that. And indeed, we do have a polar front on its way south through Colorado and Utah. Now, we did have an interesting model failure that took place late last week into the weekend. Now, we went over some of this yesterday in the supporter video, but I figure I might as well share it with the rest of you. All the charts you're going to see here are valid for tomorrow evening. So this is a 240-hour forecast at 500 millibars. So over a week ago, it was forecasting a big old trough in the eastern U.S. This is the European model, okay? So we move forward, and we see that trough get a lot deeper and close off into a low, and it parked it out there on Colorado back on the 2nd. Now, that's not going to be conducive to a lot of cold air coming into the central U.S. It will, of course, be significant if you're in the Rockies. And it kept that low out there over the next few runs. The 3rd had it in the Four Corners area, same on the 4th. But then it moved a little bit east and opened it up. That would have brought a lot of cold air into the central U.S. It kept it like that for about 3 cycles, and then on late Saturday, it backed it back where it was in the Four Corners area. So a little bit of inconsistency showing up there in the European model. But up until this morning, yeah, it had it pretty much right there around the Four Corners area, and that's pretty close to where we're at right now. The GFS was a little bit more inconsistent. It kept the trough and the low in the central plains. You can see that solution there even on the 3rd and 4th, keeping it there in Kansas. And only around Sunday morning did it start bringing that low westward. So this big, sophisticated global run was having problems up to about 84 hours out. Now, we shouldn't see large errors like that in that kind of range. Usually that stuff we see about 120 hours out. But these models have had a lot of problems with this system, and it does look like the European model. There's a bit of thunder. I'll have to go out and get a bit of video. But it does look like the European model did a much better job compared to the GFS. Yep, a pretty typical summertime popcorn thunderstorm. Okay, back to the studio. Okay, we might as well take you on the journey of how we put the surface analysis together. Unfortunately, it's 4 after the hour, so we're not going to get the Canadian data, so I'm going to wait a few minutes. Okay, it's 9 after. And what I'm using here is my own digital atmosphere program. I'm going to go in and retrieve data. So we should have all the Canadian and U.S. data at this point. And I've got my custom-built planetary maps here. So there's a look at the data. And since this is done on the fly, I take a quick look at the INSEP surface analysis just to kind of get a general idea of where I'm going to find stuff. That way I can run pretty quickly through this analysis. And since we only have a limited amount of time, this allows me to focus a little bit more on the production and get everything out pretty quickly. So we got our isobaric analysis there, and I use a very specific set of objective analysis settings. I've got the Cressman, got it at 60 by 60, and I've got these coefficients put in. So let's go through and add the fronts. And the first thing I do, I see this boundary here through the Midwest, and I'm looking for any closed circulations. Do I see any closed circulations? Not really. This looks kind of like an inverted trough, so I'm not going to put a low in there. I'll probably look further up the boundary for anything like that later. But as far as right now, maybe just one little low right there in the West Texas area. So I'll drop that in. Now we do have to consider this part going away from the low a warm front, but it's going to be a very short warm front. The rest of it is all going to be a cold front. So let's put that in. So I'll probably have to adjust that a little bit. Okay, that's about perfect. Now, as far as any boundaries out in the tropical air mass, I'm going to take a quick look at SPC. And that'll give me a quick idea of the convective activity. Wow, they got some serious fire alerts up there. I don't think I've seen a big old purple box like that. Let's see, we do have a little bit of convection there in central Missouri, southeastern Kansas, some coming up through our area, North Texas, East Texas, and all the way down to the coast, and then stuff in North Carolina. Okay, so based on that, I can certainly put in some frontal boundaries or outflow boundaries. So probably like that for North Carolina. We'll do a new segment there in Texas. The outflow boundary there in Texas is not very well developed, so we'll just kind of go for a small patch, maybe something like that. And then we had one through central Missouri, but that appears to not be very well developed at all. So I'm going to leave that alone. Any other residual boundaries out there in the tropical air mass? Nah, not really. Any dry lines? Not really. That's going to be way out there, if at all. So I'll save that for the Southwestern analysis. And this is the part where I start talking about it. So in the southeastern U.S., very aggressive, fast-moving cold front coming in through the Midwest, passing through Kansas there, 20, 30 knot winds behind that, and some very cold temperatures, 40s and 50s throughout much of Kansas, the Texas Panhandle, and we get back into the Lyman, Colorado area, and we're picking up snow at this time. Wind gusts up to about 25, 30 knots, And Denver, 36 degrees there with cold rain coming down. And let's see, anywhere else? Not really, just cold rain here and there, and not a whole lot of snow at this time. But some of that may be coming down as snow due to the column being cold. So I would probably want to dig a little bit more into that METAR data to see what kind of wintry weather is coming down. And there's a satellite loop for the southeastern U.S. We can see the effects of that dry high-pressure system there that has been in place across the Appalachians. There's that coastal thunderstorm activity right there in North Carolina. As we move north, we can pick up some of the structure of that cold front there. That might be the leading edge, passing through Toledo, Champaign, and all the way back through central Missouri there. So a pretty extensive system, and it looks like it's entraining some of that smoke coming out of Colorado and maybe the western U.S. But up to the north, we can see that cold air advection cumulus flowing southward. That's that cold air on its way south. And we also see that the moist air mass out ahead of the front is really not that moist. Very little low cloud except there in Ohio, Indiana, and Illinois. So there's our isobars, and we're going to continue the fronts that we drew on the southeastern analysis. So let's see, up there in Maine, it looks pretty warm. 81 around the Mount Washington area, 76 in the region just southeast of Montreal. So that's all going to be part of that warm air mass. So let's draw that in. I think the dividing line is going to be somewhere right around there. And I still don't see a close... Well, actually, yeah, I do. Yeah, there's a close low there in New York for sure. It's going to be right in there, just east of Rochester. So actually I should draw that as a little warm front segment, but I'm not going to worry about that right now. High pressure in the Dakotas and Montana. We'll drop that high right there. That's going to be a 1034 millibar high. And to its east, a lot of cold air coming south, and it looks heavily modified. If this was winter, we would expect to see teens and 20s coming down from Canada, but it looks like it's had a little bit of time to warm up. So there's the northwestern U.S., and I can see that's a little bit complicated. I can see 86 degrees there around Medford, 74 at Portland with east wind, and it looks like it cools off as you go east. Also looks like some very cool conditions there in central Nevada. The cold front has definitely come through that region. Now, one place I can get some help is with the GFS temperature anomaly. This is valid for right around the current time, and this gives me an idea where temperatures have cooled down quite a bit. And based on that, I would think the cold front is about like that, banked up against the Sierra Nevadas, banked up against the Cascades, and not much northwest extent, really. Looks like it's actually quite warm up there in the Fraser Valley of British Columbia. So there it is. Notice right there, northwest of Albuquerque, still kind of a warm sector and very likely a wave that we're going to pull up on the southwestern U.S. chart. So we're not going to worry about this area till we get to the southwest U.S. chart, but I'm going to have to paint in this stuff. So let's see. I'm going to put that pretty much in the Sierra Nevadas. So let's go about like that. Then I'm going to convert that over to kind of a area frontalysis in northeastern Washington. So there we go. Looks like most of it's covered by this large high pressure area. Large polar high in the process of modifying. And it's going to be quite unstable because these modification processes give a cold over warm situation in the lowest third of the troposphere there. So as a result, there's going to be a lot of cumuliform clouds through this area right there, and of course, snow showers. And there's our satellite loop there showing the impressive smoke plumes and a lot of easterly flow That's showing that a lot of the dense cold air is pretty much trying to spread through the passes in the Cascades. And then down to the south there in Utah, we can see a closed low in the Salt Lake City area and what looks like a little baroclinic leaf across the Rockies. And then further out to the north, there's all the cumuliform clouds associated with the cold air advection. And then finally, we bring it on home with the southwestern U.S. sector. Here we can certainly see the front. There it is right there through Flagstaff, Winslow, and on up towards Farmington. So that's showing up surprisingly well for a western U.S. cold front. And then we know that that's going to loop around kind of like that. We get back into that sector where the cold front is spilling down through the high plains. So we're going to paint out the fronts kind of like that. And based on this right here, I'm going to go probably something like that for the front. Looks like a little bit of frontal lift up there northwest of Albuquerque. All right, so let's do it. So as it paints the isobars, I'm kind of reviewing the plots and kind of sizing up what I see here. Very dynamic pattern across the southwestern U.S. there. You can see the 82 degrees there at Gallup with very strong southwest winds gusting to 41 knots. And then you go west on I-40. We pick up the cooler air and the 74 degree temperature, northwest winds there at Winslow. And then when you know it's, when you see 79 degrees, north winds at Vegas in early September, that means frontal passage. Very rare for this time of year. All right, so let's put in that frontal analysis and finish it off. Yeah, it's certainly come through Albuquerque there. They've got very likely canyon winds to the west, to the east of there. The airport there picking up 41 knot gusts. So we're certainly going to bring that up to the north. Then we're looking for that frontal wave, which I think is around the Durango area. That looks to me like it's somewhere up there. So there's our frontal boundary in New Mexico. And then I'm going to bring this back. Obviously, frontal system moving through Holbrook, through Prescott, and looks like that is coming up on the Mojave Valley. And then that's going to link up to that front there near Mono Lake and Bishop. So there you go. That's the frontal analysis, and I would imagine that front is going to be moving up on Phoenix here this afternoon. Drop a little heat low there. Looks like maybe, some troughing in here, maybe a low around Deming. And that's about all I can find there. Okay, so that's our surface analysis, and do I see a dry line out here? Not really. You could probably put in kind of a weak one around Fort Stockton, but I'm not 100% sure that that's there. Anyway, a very impressive, very dynamic weather system for early September. And let's zoom in on where all that action has taken place. This would be a very interesting day to be driving on I-40. Yeah, you can see that front right there. Yeah, watch it go through the Albuquerque area. Albuquerque located about right there. You can see it just kind of move on through there. And we can see one little thunderstorm going up there near Guadalupe Peak. Let's run that through and see that pop up. Yep, that's coming together. And some very impressive gravity waves out around Lubbock and Snyder, the Cap Rock. Well, it would be nice to have some relief, but you can see that the southward progress through Texas is very lethargic. Front makes it into the Fort Worth area, well, just west of there tomorrow. And it looks like maybe a few thunderstorm elements get going and helps it surge eastward, but not very far. And just not much eastward progress at all. And that's given the air mass quite a bit of time to modify, so by the time this finally pushes through, we're only going to be seeing 60s and 70s out to the east. And there's a quick look at the thunderstorms. This could help reinforce the front. The models are pretty well known for underdoing the contribution of outflow air into the frontal pool. So we shall see how that goes. So 23 minutes in, and we're finally getting to the NHC products. We've got Paulette out there, tropical storm, and Rene. 5-day outlook. Looks like Paulette going mostly to the northwest, and likely the same thing for Rene. But looks like there's some concern about this next easterly wave coming out of Africa, and if we throw that a little bit further south, that's going to have a better opportunity to make it towards the U.S., but that's still over a week away. And then looks like we have this one little wild card out there. Weak disturbance could affect the Carolina coast here in the next few days. And sea surface temperature, very important right now because September 7th, September 8th, that's when it peaks. The ocean has a very high specific heat, and so even though the atmosphere peaks in terms of heat in late July, the ocean peaks in early September, right around this time in the northern hemisphere. And there's what we're looking at in terms of temperature anomaly. The Atlantic definitely above normal. Anything in the orange warm shade is above normal. So this little pocket right there off the Carolina coast, that's going to be about 2 degrees Celsius above normal. So you'll want to keep close tabs on the weather this afternoon and evening, kind of like what I'm doing here, and you'll probably see some very neat stuff, especially on these satellite loops and maybe on the radar. And that's all I have for this edition of Forecast Lab. Hope you enjoyed it. Take care, and we will see you tomorrow. Bye-bye.